I just, oh, thanks, Bonnie. I just want to give a quick prologue. And so this talks all about the Hawaii Cesspool Prioritization Tool, the HCPT. And my prologue for this is, why is this widely used and well known? So maybe it's not super well known in this room, but in the halls of the Hawaii State Legislature, this tool was mentioned and utilized in a number of bills in the last 2 years. It's been utilized in grant eligibility decisions in Kauai County and across the state with Department of Health. And really kind of the key message for my presentation today is all about the fact that we start with this really complicated situation. So I'll go pretty in depth about the background as to how we got into this situation with cesspools in Hawaii. And it's really complicated, and it's a really tough nut to crack. There's a lot of factors, and it's really politically challenging, and there's a lot of things to consider. Specifically for our tool, we start with 1.2 million things to consider, and then we break it down to 3 things. So really, it's all about taking a lot of complexity, something that's really has a lot of sides to it, and then just simplifying it as much as possible for that policy management and public outreach purposes. So this is my prologue, and I'll give you all the background here. So hopefully all of this will make sense in a little bit. So first things first, I wanted to share a fun fact that if you don't know what cesspools are, I will share that they are pretty old technology. 6,000 years ago, the ancient Babylonians used the first known wastewater disposal system, which were cesspools. And in Hawaii, we are still using these today. So if you don't know what it is, pretty simple. It's basically an open or a pit in the ground. Usually it's covered up. Usually they're not open, but it's just a pit in the ground. That's it. And with perforated sides, your wastewater collection pipe, like your toilets and your sink and everything, all go into one pipe that goes into, usually a big 3-4 inch pipe that goes out into the yard. If you have a more advanced system like a septic tank, it drops in there, or it goes into the sewage collection system. Otherwise, if you have a cesspool, it just drops into a hole in the ground and percolates straight down. So that's really a limited amount of wastewater treatment is the problem. A little bit of historical background here, just because I love to get into the history of anything I'm doing. It's always interesting. And I'm a hydrologist by background, so I'm not a wastewater engineer or anything. So I have kind of limited wastewater understanding and training, but I did find that the first mention of a collection system in any wastewater disposal in Hawaii came from around the 1850s, 1860s. And actually, King Kamehameha IV is the first person to have a flush toilet in Hawaii, just in case you didn't know. Back in the 1800s, though, health issues were a big deal, right? This is like the time of cholera, and smallpox had not been eradicated yet, right? So people, public health is a huge issue back in that time. And wastewater is identified as one of the vectors of disease that, were really detrimental to society back then. So that was already kind of identified. We knew wastewater was a problem, basically, even before all the fancy science that we have now. And then, from the historical context too, this cesspool issue really started going, sort of started forming in post-World War II, right? So after World War II, there was, a development boom in Hawaii. And in the 1960s, even though people knew that cesspools were an old-fashioned form of wastewater treatment, officials were reluctant to ban them because that would halt development. And, Hawaii was a rapidly developing territory in the 1959, a state. And, a lot of the development that we have, a lot of the people in Hawaii live in houses that, came from this era or even before in the plantation era, right? So this problem's been around for a long time. So what exactly is this problem? I mentioned cholera is one thing, so we don't worry too much about that these days. But now, the science that has been being put together really since around kind of, the late 2000s, really started exposing the risks of human impacts and development especially on coastal zones and aquatic environments. So this is kind of actually how I personally started getting involved in this issue as a hydrologist, as a water quality scientist. I didn't do any of this, I didn't participate in any of the studies that are up on here, but these are all folks that were my mentors or collaborators. Folks like Megan Daler and Celia Smith, who really started investigating this issue in the late 2000s and identified how nutrients from wastewater is a major driver of coastal eutrophication and algae overgrowth. So a lot of those are invasive algae. And a lot of folks have done a lot of really great coastal work identifying how wastewater nutrients, this is specifically an imbalance in nutrients that are released from wastewater, can wreak havoc on coastal ecosystems, on our really important coral reefs. They also are impactful to streams as well, not just coastal health. And, again, one of the, big drivers of the work that we're doing is human health. And so, there have been a number of studies that have linked wastewater discharge to higher counts of enterococcus bacteria, higher counts of staph infections, and things like that affect our recreational swimmers and our keiki that are out in the ocean. And then finally, cesspools do not only affect coastal waters, but also our drinking water. So 99% of Oahu's drinking water is pumped out of the ground, comes from groundwater. And cesspools discharge effluent directly into the ground, right? So it doesn't take a scientist to put two and two together. Although there's not very many studies that can really identify this because it's pretty tricky to sample groundwater and really identify exactly where those excess nutrients are coming from. But there's been a couple that have done a pretty good job of it. So, we know this is an issue. It's not contested anymore. So back in the 2000s, really the message that scientists and folks in my department were trying to convey is that cesspools are a problem. We know it's a problem now. It's pretty obvious. Here's a legislative timeline, but I'll just point out right here, Act 125 in 2017 mandated the statewide cesspool conversion. So all cesspools needed to be shut down, converted. No new cesspools could be built. It's a big project, so they gave us a lot of time by 2050. Prior to this, people had talked about it. Again, I mentioned in the 60s, they knew this was a problem. In the 80s, Department of Health really started trying to push for this, but then, kind of realized that they didn't have the regulatory, teeth or authority to close these cesspools statewide. So it really took an act of the legislature, and that was Act 125. So it's a pretty bold act, pretty kind of politically divisive, but it's a big move by the legislature to ban these. So they said, and that was 2017, right? So they said, all right, well, we got 33 years. Now it is 2025, so we have only 25 years left, and we're still trying to figure out how to get this done. So part of that figuring it out, started in with Act 132, the year after 125 was passed, and that formed the Cesspool Working Group, and this was a group of experts and county officials and people from the real estate industry and all kinds of stakeholders to start talking about and identifying how we can address the issue. And that was actually where we got the initial funding to start the Hawaii Cesspool Prioritization Tool from the Cesspool Working Group funds. So I'll be talking specifically about our little part in this. I also mentioned earlier that our tool has been used in some of the appropriated grant funding. So there's a pilot program to give funding to homeowners who had cesspools to convert, so low-income homeowners. They appropriated $5 million. I think it disappeared in like a day or a week or something like that. But our tool was actually utilized. Only the priority 1 and priority 2 homeowners from our tool were eligible for that. And then now we're currently working on a new project. I've got a couple slides at the end of this from Act 217 to add sewer expansion planning to this as well. So that's kind of the background of, where we have been, and, this is where we are. So if you've read the news lately, Civil Beat, they do lots of great reporting on, everything, of course, but on cesspools. So there's lots of civil beat articles, even Associated Press articles, national news. And, the headline is we still have a serious cesspool problem. There are a lot of cesspools in Hawaii, over 82,000 of them. So this is one of Hawaii's biggest questions. One of our biggest legislative priorities right now as we go into a legislative season. This is a really big question. This is a really costly question. So if we were to convert every cesspool, every 82,141 of these cesspools, to a septic tank, the septic tanks usually cost about $50,000 to install. Kind of an average estimate, depending on the type you use. That's a $4 billion question. So this is a big issue for the state. How are we going to handle this? Well, our project, just like any big problem, you got to start with baby steps, right? So, each of these cesspools is going to be handled one by one. And here's our research question for our project. It's really about which ones first, which ones are the most important, and which ones do we prioritize? So, big problem. Let's break it down into smaller pieces, right? We're not the first ones who have done prioritization across the state of Hawaii. So in 2017, Department of Health, they put out some work, essentially identifying areas where there was high cesspool densities, and kind of drew circles on the map and said, these might be good places to start. But with Act 125, what we wanted to do, what we proposed to do, was to improve that prioritization by really doing an objective kind of framework to do a little bit better job of taking all of the factors that are important to different stakeholders and incorporating those into a single tool. So that's how the Hawaii Cesspool Prioritization Tool was born. And the overall goal was to rank all of Hawaii's cesspools. The 2017 prioritization left a lot of them out and just said, these we don't have enough data for. And we wanted to prioritize them based on their individual as well as collective impact to human health and the environment. So the way that we started looking at this was to look at the individual drivers of health risks, environmental and human health risks. So what are the key data sets that we can gather and incorporate to really create a risk management framework? One of the really key things that we wanted to do is make this a scientifically unbiased and objective framework. This is a highly politicized, hot-button issue that's going to cost Hawaii homeowners a lot of money. So we knew that this had to be bulletproof because people argue with it, people don't like it, people say, oh, you should do it this way. All of the decisions we made in a way that were transparent, open source, reproducible, and, again, kind of as objective as possible. And then, as I mentioned earlier, this tool incorporates basically 1.2 million pieces of information, and we wanted to make that really simple, easy to understand, so that our results could be utilized by policymakers, by managers, by homeowners. And so the way we're doing that, too, is to also make it really accessible on a public-facing web application. So I'll talk a little bit about the data pipeline, because this is a data science seminar after all. It's actually pretty simple. If you look at it, really, there's only 3 input data sets. One of those is our 82,000 cesspool locations. Then I mentioned that we looked at those different risk factors. So we identified 15 risk factors, which I'll go through later. And then we also settled on some specific geographic boundaries to help with simplification. So taking all these things together, what we basically did is put them into a big Jupyter notebook. So if people are familiar here with Jupyter notebooks, you may or may not love them. As a non-data scientist, I love them. And one of the reasons I love them is because not only do you put code into them, but you can also put so much more richness, graphs and markdown and images and all that kind of stuff. So really the notebook is the narrative of how we go from where we're starting to where we're ending. Everything that we did, we're doing it as transparently as possible. All the code's up on GitHub, all the input layers that are not sensitive layers, they're all in the repository. That's all been pushed to a stable Zenodo repository with the DOI and whatnot. And so everything about this tool we're trying to make transparent and accessible. And then what it does is it basically takes all of these factors and then ranks every cesspool in the state into either priority 1, which is the highest priority 2, or priority 3. So really simplifying this in a way that's, kind of traceable and reproducible. And you can trace it right through this Jupyter notebook if you're interested in looking at that and seeing, every single decision that we made in order to get from start to finish. A little bit about the data workflow. There was a good amount of data cleaning, and we're still working on this now. We'll be publishing papers soon, hopefully with a new updated inventory for 2025. This tool represents the 2021 inventory. Here's all those input layers, and I'll just run through those real quick in the next slides. So every single cesspool was basically connected to each one of these data layers and obtained a score for every single data layer. So we mapped those values to each of those 15 input data sets. In order to generate those scores, we developed some kind of customized algorithms, mainly based on how groundwater flows. That was kind of the scientific basis of it. I'll talk a teeny bit about that too. And then to simplify, we tried to turn that into risk scores, so risk factor scores for each of these input data sets. So then we have 82,000 cesspools times 15 risk factor scores. We also weighted those because some of those risk factors are more important than others. And then we aggregated them by census boundaries because those are pretty stable boundaries and represent population dynamics. And then we just use quartiles to bin these into priority 1, 2, and 3. So a pretty simple method to prioritize them. I mentioned we have 15 of these factors. So for each one of these factors, we're multiplying all 141,000 of those cesspools times the 15 factors, and so that's where we get to that 1.2 million numbers that we're taking into account. And so these are just some maps of the things that we considered. So cesspools that are closer to the coastline will have a greater impact on coastal resources than ones that are farther away. So the ones that are closer ended up getting higher scores. Kind of the same thing for wells. Ones that are closer to drinking water wells are going to have a higher impact on those wells. So those scores were all calculated geospatially based on their distance. We looked at soil properties. So different soils will attenuate effluent in different ways. We also looked at sea level rise vulnerability. This is one of the things that the Department of Health really wanted us to examine because the previous prioritization hadn't considered future climate change at all. So identified where cesspools would be influenced by sea level rise, either from horizontal inundation or inundation from below by raising the water table. We looked at how close they were to streams or wetlands, and they got a score depending on that. We looked at how close they were to the groundwater. So for example, these ones up here that are very far away from the groundwater, there's going to be more time for bacteria to attenuate, for nutrients to spread out and disperse before they hit the groundwater and start mobilizing. We also looked at if they are in well capture zones for municipal drinking water wells. So these are the wells that go into the county water supplies. Density is also a big factor because cesspools that are far out and just individual, there's a lot of space around them. There's a lot of soil and, low levels of microbes to attenuate those nutrients. When you start getting into really dense areas, the amount of effluent, the amount of nutrients can really start to overwhelm the environment's ability to attenuate that. And so cesspools that were in a higher density area got a higher score. We looked at rainfall because rainfall dilutes cesspool effluent. Slope as well. This was actually kind of fun when we identified where on the coast people were more likely to be visiting or using the coastline. So, identifying areas that are highly used. We did this by scraping photo sharing data. So, the geotag location off of photos from Flickr. So that was a fun little project. And I don't know if anybody's made a map like this, but this is, from those Flickr photos. It's probably pretty dated because nobody uses Flickr anymore. But, from the data set at that time, You can identify where there's a lot of people visiting, where there are not a lot of people visiting, like, on the outside of the airport or at the marine base, lots of people up at pipeline or whatever. And then we could link the cesspool effluent discharge to those locations along the coast. We also linked the cesspool effluent discharge locations to where there was high value coral cover. We've teamed up with some of our marine biology team members and with the Highmark group, and they developed these coral cover, coral value data sets, as well as reef fish recovery potential data sets, and linked the cesspool effluent discharge locations to those, as well as where people are swimming based on where there's lifeguard towers. And then we also sort of identified a proxy for dilution, because where you have a lot of dilution or wave energy or currents, effluent's going to spread out farther, you'll have lower nutrient concentrations, and you won't have as big of an effect. So we tried to incorporate that as well. So these are those 15 factors that all boil down into our scores. And I'll just mention real quick some of the algorithms. So those particular risk factors that had a distance to them, we needed to identify a way to give them a score, and it couldn't just scale linearly. So we scaled it, based on this kind of like decay function. And that decay function is basically modeled off of one-dimensional groundwater effective transport of solutes and how they spread out in the aquifer. So that's kind of a basic proxy for how we think that effluent would behave in the subsurface in a pretty idealized setting. What we also did is we incorporated groundwater model solutions into this, because a cesspool that's way up here, you know that effluent's going down into the groundwater and that's going somewhere, but the best tool to predict where that somewhere is a groundwater model. So we took statewide groundwater models and ran particle tracking flow paths for every single one of the cesspools and identified where the effluent would most likely discharge. And this is how we were able to link up inland cesspools to those coastal parameters, to how they would affect coral, reef fish, swimming beaches, things like that. I think this is the swimming beaches layer, where you've got cesspools that are affecting a swimming beach in red, ones that are not in green. I think that's what this layer is. And yeah, so that those groundwater models were essential to link, again, these inland effects to their coastal impacts. And then finally, we also did some weighting of each of these factors, because one of the things that we realized was that each of these factors do not have the same importance. Some of them are more important than others. But, as you all know, as objective data scientists, how do you define what is important in an objective way, right? That's a value judgment. It's, inherently subjective as to what people value. So what we did is we convened a panel of experts, and we had a couple of different workshops where we got everybody together, we talked about the tool, we talked about all the factors, and we asked them to rank each one. And with that, we pooled all of that data together to basically assign weights between, I think it was 1 and 4. So, for example, the distance to municipal drinking water wells, that was identified as a very important factor. So that one, the experts scored that as much higher. So that one got a higher weight than, for example, average annual rainfall, which got a lower weight. So that was the best way that we could think of to, really think of an objective way as much as possible to weight those factors without, cherry picking one or the other. So again, I mentioned, this is all in GitHub. We did it with Python. Specifically, we used ArcPy. So if you're familiar with Esri's products, ArcMap, ArcGIS, ArcPro, there's an ArcPy module, which is super easy to work with. And you can do it in any, or actually you have to do it in their licensed Python environment, because you have to pay for a license. It's not open source software, but then the code can easily be open source and, be understandable by everybody. And here's just a visualization of how we took, all those 15 factors at the top, and this is actually the final score, aggregated them all together to come up with a final score. And those final scores are all aggregated based on census tracts. So we aggregate them based on census tracts, blocks, and block groups, which are, basically the boundaries that a lot of research data is collected on. I think, I don't know if voting districts are based on this, basically the kind of US federal government division lines, boundary lines between different areas, neighborhoods, towns, things like that. So we chose census tracts as our main kind of boundary line because it basically encompasses, essentially our towns, like the town of Waimanalo is in one census tract, for example. And then we had all of these numbers, so every census tract had a score, and so we actually do, every single cesspool has its own score, so we can refine it, to 82,000 ranks, but we thought that 3 ranks would be more useful than 82,000, so we just bin these where the top 25% quartile are the highest priority cesspools, the middle 25% is medium priority, and then the bottom 50% is the lower priority. And so that's just breaking up that data set into 4 quartiles, and then the bottom gets 2 of those quartiles. And all of this to say that we made this cool tool, and yeah, sure, it's on GitHub, and that's really useful for folks in this room, but maybe not people in the legislature. But so in order to make that more accessible, we put together a website, so you can check that out at hawaiicesspooltool.org, or you can check out and use our QR code right there. And this was back in 2021 before everybody was making, the Esri web map apps. So we thought we were really cool. We use the Esri web app developer edition, it's like one of those kind of prepackaged JavaScript libraries. And we made a couple tools. One of them shares the input data, and then one of them shows the results of it. So it's a little dated. We're actually updating it in our new project now. But that, has really made our project, really accessible. So people can go on there, check out the map, look at the different colors, and, start to try to understand this issue. We also got a great videographer, awesome guy in California. I think he works on like Gavin Newstrom's campaign videos. And he squeezed us in between this and made these really great Hawaii Cesspool Tool videos. So if you check out our website, make sure to check out our little 90-second videos about how to use it and why it's important. All right, so I'll take a breath here and just share some of the results, because I've been talking all about how cool this tool is, and I figure I'll just share some of the results up here on the screen for the different islands. Hawaii Island has most of the cesspools in Hawaii. They've got about 50,000 of the 80,000 cesspools, so really a lot of them are in Hawaii, in the rural areas. Maui is a good number. Yeah, especially on East Maui, up in upcountry. Oahu doesn't have as many cesspools, but has the highest number of priority 1 cesspools, or the highest proportion, 64% of the cesspools on Oahu are higher priority, mainly because of the density and the high use and the coastal development. There's a lot more coastal development on Oahu than other islands. And here's the results for Kauai. There's a lot of high priority census tracts here too, and that's a little bit of an artifact about how the census tracts are organized. They're pretty big census tracts in Kauai, but there's some clusters of cesspools there too. So just jump in real quick and share a little bit about our second phase. So this is funded by Act 217. So this is an ongoing project. We finished up the Hawaii Cesspool tool in 2022, and it's been running. And then since then, the 2024 legislature, Hawaii State Legislature, put out Act 217, which mandated the University of Hawaii. So, I'm not going to say they liked the Hawaii Cesspool tool so much, but they found it useful enough to say we should build on this. And what we really want to do is answer the question of, if I am a homeowner and I am, kind of in a town area, and I'm mandated to replace my cesspool by 2050, should I go ahead and spend $50,000 on a septic tank now? Or is there going to be a sewer system expansion? So like a centralized sewer system, right? So with, a collection system that goes to a treatment plant, that then discharges somewhere. Is the county going to build one of these in my neighborhood? So that means that I should save my money to connect to the sewer system as opposed to replacing my cesspool. Apparently there was not very much information about what the counties had planned. So this act was passed and our team was tasked with developing this tool. So that's what we're doing right now. The vision is to really improve our decision support for these centralized sewer system expansion projects, really by looking at costs versus benefits, kind of basic decision support stuff, right? So we can, not only identify how much different expansion systems will cost, but we can also look at the benefits in terms of not just the number of the cesspools, but the priority ranking and all of those 15 factors that go into them, so that decision makers can tailor their, essentially benefit side of the equation to focus on those priorities that they're most interested in. And we can even target specific mitigation. We can calculate how much nitrogen would be removed by a project that costs X amount of dollars. That's a really useful kind of metric as well. So the way that we're doing that is by identifying areas that would be viable for sewer system expansion, basically where there's a high density of cesspools, and taking all this information and putting it all together into a separate web application. So we're actually going to have 3 web applications for the Hawaii Cesspool Prioritization Tool. One of them is the results that I shared, the red, yellow, and orange results that a couple of slides that I had a couple of slides ago. One of them will be sharing the input data layers, those 15 layers, and this new one will be our sewer expansion map. And so this is just a web application, so it's optimized for the web. It also works pretty well on mobile, and really tries to simplify things down, give a good report, give information to homeowners, policymakers, to anybody who needs it for their decision support. And that decision support can look something like this. So this is draft data. We haven't really constrained these costs very well yet, but this is the kind of thing that you can do with this tool, because we can take all that information and we can say, okay, each of these dots is a project area. This is how much that project costs per cesspool, so based on the number of cesspools that you convert. And then this is the impact, and here we're just multiplying the number of cesspools by the weight. And so this is just one way you could look at the data that we're collecting together in this tool in order to say, okay, well, these projects down here on the lower end of the cost scale and the higher end of the priority scale, those are the important ones. Those are the ones we want to focus on first. These are the ones we want to focus on last, right? So, that's just an example. Again, this is draft data. So these cost estimates are just estimates right now. We're continuing to work on getting better ones together for the real tool, which hasn't been released yet. And that's pretty much what I have for this talk, I guess. Okay, yeah, 35 minutes, not too bad. So, as I mentioned, so Mike Mezzacapo and Melanie Lander, both of them used to be at University of Hawaii Sea Grant Water Resources, have both moved on. Mike Mezzacapo is at US EPA now, but they were instrumental in creating the original Hawaii Cesspool tool. Amy Shriver's in this room and is still instrumental in the tool. And then we also, really want to acknowledge Sina Pruder, who is the wastewater branch chief at Hawaii Department of Health, Cesspool Working Group. We had a lot of feedback sessions. We had a lot of meetings. This tool went through a lot of iterations. And, again, kind of that, that take-home message of really taking complexity and simplifying it. That process of simplification is not easy. So it's not something that you just say, okay, well, I'll just make it really simple like this. We went through meetings and meetings and meetings and feedback sessions and reviews to really figure out every little detail of how to simplify this in a way that worked for all of the stakeholders. So that iterative process really yielded something that we feel like we can stand behind, we feel like is pretty objective, and we feel like is, hopefully a useful tool to benefit the state and help us solve this really challenging problem. My contact information is right up there if you're interested in connecting with me, and you can always go to hawaiicesspooltool.org or scan that QR code to check out the tool yourself. Yeah, with that, I'll take any questions. Thanks.